You are welcome to study session 9. You will recall that the last time we met, we studied oxidation and reduction. That was in study session 8. We want to continue our study in this session 9, and we are going to consider electrochemistry. At the end of the lesson, we should be able to do the following. 1. Define what electrochemistry means. 2. Explain the nature of electrochemistry. 3. Explain electrochemical cell, and at the same time be able to discuss how corrosion can be controlled. From the word electrochemistry, two words, electro and chemistry. A branch of chemistry that deals with the transformation of electrical energy to chemical energy is called electrochemistry. Electrical energy, we are converting it to chemical energy. A simple electrochemical cell is as shown. We have the electrolyte, and those are the ones that are in solutions, zinc 2+, copper 2+, NO3-, those are the ions. We have the rod, the two rod. The one to the left is the zinc rod, and the one to the right is the copper rod. And there is a porous partition that partitioned one of the cells from the other one. There are two terminals. The first one, we have the negative terminal and the positive terminal. The negative terminal is called the anode, and the positive terminal is called the cathode. The direction of flow of electron is from the negative to the positive, and normally current flows in opposition to electron. So if the current is flowing now, it will flow from the positive to the negative, whereas the electron will flow from the negative to the positive. Electrochemical corrosion. Corrosion is a destructive attack of a metal by a chemical or electrochemical reaction with its environment. Examples of corrosion are what we see in our day-to-day activity. If a nail is thrown outside and rain fell on the nail, air blew on it, after some time you see a brownish substance forming a coat on that particular nail. What occurs is called corrosion, and that is a destructive attack, because if it is left for a very long time, the time will come when the nail will no longer be useful, to wear out. The old roofing sheet, you discover that when it was first done, it will be shiny, but after some time it will look brown. What has happened is corrosion. So corrosion is what we come in contact with in our day-to-day activity. Having known that it's a destructive attack, there is a way to control it so that it will not destroy something that is of value. And there are three ways of doing that. One, we need to condition the metal in such a way that once it is conditioned, the effect of the external influence by either chemical or chemical reaction will not affect the metal. The second one, we will condition the corrosive environment. The environment that causes corrosion can be conditioned in such a way that it will not cause corrosion. And lastly, it could be done by electrochemical means. This can be done by either galvanizing or electroplating. Those are the ways to control corrosion. Factors that control the corrosion rate. There are two of them. One, establish a well-defined location on the surface for the anodic and cathodic reaction is one of the factors that controls the corrosion rate. This concentrates the damage on small areas where it may have serious effect. This being described as a local cell action. And such effect can occur when metals of differing electrochemical properties are placed in contact, giving a galvanic couple. The second one is a stimulation of the anodic or cathodic reaction. Stimulation of the anodic or cathodic reaction. These could be explained as aggressive ions such as chloride tends to prevent the formation of protective oxide fields on the metal surface and thus increase corrosion. Sodium chloride is encountered in marine condition and is spread on roads in winter. Then, quite small concentration of sulfur dioxide released into the atmosphere by the combustion of fuels can dissolve in the invisibly thin surface film of moisture, which is usually present on metallic surfaces when the relative humidity is over 60 to 70%. The acidic electrolyte that is formed under these conditions seems to be capable of stimulating both the anodic and cathodic reactions. Faraday's laws of electrolysis. There are two laws that Faraday came up with. The first one is called the first law, and the second one is called the second law. So let's take a look at the law one after the other. The first law is talking about the relationship between the mass liberated or deposited and the quantity of heat that is passed to the electrolyte. It states that the mass of an element liberated or deposited during electrolysis is directly proportional to the quantity of electricity that is passed through the electrolyte. In other words, it's a relationship between the mass and the quantity. Whereas the second law is talking about the relationship between the mass and the charge. Second law states that when different electrolytes, when the same quantity of electricity is passed through different electrolytes, the mass liberated will be inversely proportional to the charge on the ion. So in other words, the second law is talking about mass and the charge in an inverse relationship. But the first law is talking about the mass and the quantity in a direct relationship. So let's take a look at the mathematical representation of both the first law and the second law. So the first law is talking about mass proportional to the quantity. And from a knowledge of mathematics, when we remove the reagent sign, mass becomes KQ. From our knowledge of physics, Q equals to IT, that is current times time. Substituting that equation into the one above it, let's say this is equation 1, this is 2, and this is 3. We're substituting 3 in 2. So we now have M equals to KIT, where M is the mass of the element liberated or deposited during electrolysis, K is the electrochemical equivalent, I is the current that is passed in amperes, and of course T is the time for the exercise in seconds. The second law, like I said, the first law is considering relationship between the mass and the quantity, but the second law is considering relationship between the mass and the charge. Mass inversely proportional to the charge of the ion. If you have three different ions, we have sodium ion, copper ions, and aluminum ions. The mass for sodium will be mass proportional to 1/1 because the charge is 1. The mass for copper will be mass proportional to 1/2 in an inverse approach. And the last one, the mass will be inversely proportional to 1/3. In other words, 1 Faraday will liberate 1 mole of a monovalent ion, 1/2 mole of a divalent ion, and 1/3 mole of a trivalent ion. That is what the law is all about. Want to look at an example? I think I've been able to illustrate that using this proportion, this equation, mass proportional to Q, M equals to KQ. And recall this has been done. These are the parameters. M is the mass deposited, K electrochemical equivalent, I is the current in amperes, and of course T is the time in seconds. Let's take a look at one example. A metal with atomic mass of 27 is deposited by electrolysis. If 0.17 of the metal is deposited on the cathode when 0.15 amperes flow for 3.5 hours, what is the magnitude of the charge on the ion of the metal? To solve this problem, we use relation. This small letter n indicates, the one to the left indicates the charge, that is the number of electrons, which is the charge. The capital M stands for the relative atomic mass of the metal. I is current, T is the time. Then this is a constant called the Faraday constant, 96500, that's 1 Faraday. And this small letter M is the mass deposited. Note that capital M is the relative atomic mass and small letter m is the mass deposited. The information are here to supply. The mass has been given as 27. The current is 0.15 amperes. We multiply by that. And the time we are given 3.5 hours. We converted the hours to seconds. That will be 3.5 times 60 times 60. And that gives us 12600. divided by 96500 multiplied by 0.176. A careful evaluation gives N equals to 3.004. It means the charge on the iron or the charge on the metal in question is now plus 3. The charge is plus 3. Thank you for listening. See you in the next class.